Hello, this is Dr. Donna Burnett. In this lesson, we will learn about vegetables and legumes. Let's get started. By the end of this chapter, you should be able to draw a plant diagram describing how vegetables are classified, create a flow chart illustrating all the parts of vegetable composition, discuss factors influencing vegetable purchases, define legumes and their food products, describe ways to prepare vegetables using dry and moist heat, and list the refrigeration, freezing, and dry methods of storing vegetables. How many of these legumes have you tried? And these vegetables? The classification of vegetables can be seen as roots, bulbs, stems, leaves, seeds, and flowers. The diagram on the right, which is figure 13-1 in your textbook, shows the classification of vegetables along with some examples. The fruit of the plant is the part of the plant that contains its seeds. Specifically, this is the mature ovaries of plants. If it derives from a flower, it is usually a fruit. Examples of fruits: tomatoes, squash, cucumbers, avocados, okra, eggplant, olives, water chestnuts, and peppers. When we consider the composition of vegetables, you see on the right the plant cell. You have the plasma membrane, the cytoplasm, the nucleus, the cell wall, which is different than an animal cell, which has a cell membrane. Plants as functional foods are valued for their phytochemicals or phytonutrients, and that would be the non-nutritive component in plants that are considered to have positive health benefits. Let's take a moment to explore this website that tells us more about phytonutrients. In the UC Davis Department of Nutrition, they have quite a bit of information about phytochemicals, and I thought it would be a good idea to pull this up and take a look instead of trying to copy it over to your slides. You can also go back to this link if you would like to learn more. What are phytochemicals? They are bioactive compounds found in vegetables, fruits, cereal grains, and plant-based beverages such as tea and wine. Phytochemical composition and consumption is associated with a decrease in risk of several types of chronic diseases due to, in part, to their antioxidant and free radical scavenging effects. Recent research has also highlighted their potential role in improved endothelial function and increased vascular blood flow. Figure 1 shows types of phytochemicals. You have phenolic acids, flavonoids, lignans, and then you have anthocyanins, flavones, isoflavones, flavonols, and under there you have even more breakdown of chemicals. Vegetables also can have additives. Fresh vegetables usually have few or no additives, except there is some naturally occurring silicon dioxide and wax, and sometimes wax is added if they're replacing the wax from having washed the fruit or vegetables. And canned vegetables can have EDTA to preserve, salt and sucrose, sodium bicarbonate, and BHA and BHT. Here are some of the phytonutrients we will discuss. In this lesson, we're looking at the pigments of carotenoids, chlorophyll, and flavonoids. Under carotenoids, we will look at carotene, lycopene, xanthophyll, lutein, and xanthan. Under chlorophyll, we'll look at chlorophyll A and chlorophyll B. And then under flavonoids, we'll look at anthocyanin, anthocyanin, and betalain. Let's look at these in a little more detail. Let's take a little bit closer look at carotenoids, chlorophyll, and flavonoids. So in the carotenoids, we have the yellow-orange color vegetables. We have in lycopene the red-orange. In xanthophyll, we have the yellow vegetables and fruits. In the chlorophyll category, this would be the blue-green and the green colors. And then in flavonoids, it would be the red-purple, think purple cabbage, Xanthocyanin, think cauliflower. Betalains, think beets. Carotenoid pigments are colorful from yellow through orange to some reds. The presence may be masked by the intense pigmentation of chlorophyll in unripe fruits. There are 300 different carotenoid pigments that occur in varying amounts and locations within cells, and this is responsible for the range of color that we see. Carrots, oranges, peaches, pineapples, pink grapefruit, red and yellow peppers, tomatoes, watermelon, winter squash are some of the carotenoids that we see in our vegetables and our fruits. This can include beta-carotene, which serves as precursors to vitamin A in the human body. These are fat-soluble. It has been found that cooking carrots actually increases the level of beta-carotene. The reason is that raw carrots have tough cellular walls, and when we cook the carrots, we increase the antioxidant power of lycopene. Heating changes the chemical structure of lycopene to make it more bioavailable. Chlorophyll. When vegetables containing chlorophyll are heated, a gradual color change occurs. First, there's an intensification of the bright green of chlorophyll as air is expelled from the tissues. Second, there's a slow transformation to an olive drab. That occurs with the breakdown of chlorophyll 5 to 7 minutes after heating begins. I want you to think about fresh broccoli that's steamed and how it's intensely green. And then I want you to think about broccoli casserole that's been baked in the oven in a cream of mushroom soup with crackers crumbs on top for 45 minutes, and the color of that olive drab. Broccoli, Brussels sprouts, cabbage, kale, and mustard greens. These are all examples of foods with chlorophyll. Cruciferous vegetables, such as broccoli, have a protective effect against cancer in laboratory animals. Chlorophyll is also fat-soluble. Here's an example of what happens to broccoli. Within the first few minutes, it takes on the vibrant green color, but if it's continued to be exposed to heat, you end up with the transformation to the olive drab that I described in the broccoli casserole. To retain chlorophyll, we want to boil vegetables without a cover. Heat the water to boiling before adding vegetables. Use a slight excess of water to dilute the acids. Blanch vegetables, expelling air from intercellular spaces. Shorten the cooking time and add a bit of baking soda to increase chlorophyll retention. But you don't want to add too much because you could have an unpleasant effect on texture if the pH goes above 7. You also might experience nutrient loss of thiamine. Many flavonoids act as antioxidants, possibly reducing the risk of cancer and other diseases. Flavonoids are water-soluble. Betalains in beets, anthocyanins in purple and red cabbage, radishes, and anthocyanins in cauliflower and onions are some examples. Factors that affect the pigments would be their solubility, whether it's fat soluble or water soluble, the pH, heating, and the presence of metals. Here's an example, another example before we go on, of some additional images of food items in the different categories. Carotenes lend reddish orange hues to carrots. Radishes are red because of anthocyanin. Cauliflower's cream color is from flavones, flavonols, and flavonones. And beets derive their color from betalain pigments. These are categories that you will want to learn. Let's move on to the composition of vegetables in terms of fiber. In figure 13-8, you see vegetables that are high in fiber, a half cup cooked unless otherwise noted. If you look at the top, you have lentils at 8 grams of fiber for a half cup of cooked lentils, all the way down to navy beans, lima beans, kidney beans, peas, broccoli, parsnip, potatoes. This is with skin, a medium potato, corn, And then you have some of the same categories: corn, Brussels sprouts, carrots, green beans, spinach, and sweet potato, half a medium. So 2 grams might not seem like a lot, but if you have several vegetables at a meal, you can see how it would easily increase your daily fiber over what the average American eats for fiber, which is not very much. Another benefit to vegetable consumption is their calorie value. They are relatively low in calories, especially the non-starchy vegetables. And this is based on 1 cup cooked or 2 cups raw. The calories are provided in parentheses. So in the non-starchy vegetables, you have 3 categories: the 0 to 25 calories per 1 cup cooked or 2 cups raw. And then you have the 25 to 50 calorie category, and then the 50 to 100 calorie category. And you can see as each category gets a little bit higher in calories, we're also talking about a little bit more starch. Okay, take a minute and look at the items in these lists. Now let's talk about the starchy vegetables, and these would be 100 to 200 calories based on 1 cup cooked or 2 cups raw. Okay, so you start seeing a little bit more with corn, potatoes, winter squash as opposed to summer squash, sweet potatoes. Then in the 200 to 300 category, we are talking about beans, not green beans. These would be the starchy beans. Creamed corn, because there's more volume of corn there. Lentils. And then in the 300 plus category, we see baked beans and hummus. Looking at the composition of the cell wall, this is where the fiber comes from in our vegetables and fruits. We have cellulose, which we talked about in the chemistry of food composition, hemicelluloses, pectic substances, lignin, and gums. Pectin serves as a cement between and within the cell walls. Hemicellulose and cellulose gives firmness and elasticity to vegetable tissues, contributes to the structure of plant foods. Lignin is responsible for toughness of older broccoli stems and carrot cores. This is increased in concentration as the vegetables mature. And then gums absorb water and swell. There's limited caloric contribution due to limited digestion and absorption. Gums are added to processed foods to increase their viscosity. Let's talk about grading vegetables. Most produce deteriorates too quickly to grade, so most grading is voluntary. It is based on ripeness, color, shape, size, uniformity, and freedom from bruises and signs of decay. Here are the grades in Table 13-2, the categories for processed and fresh fruits and vegetables. You have the top grade, which is U.S. grade A, or it's called fancy. This is the highest grade for canned and frozen vegetables. They are the most tender, succulent, and flavorful, and they have the best color for type. Grade B, the majority of canned and frozen vegetables. These are not as tender or as well colored as U.S. grade A. Then you have grade C, or standard. These canned and frozen vegetables are usually more mature, less tender, and not uniform in shape or color. They are an excellent buy when cost, but not in appearance. And if appearance is important, then that would not be the best choice. U.S. grade C vegetables are frequently utilized for soups, stews, and casseroles. And then grade D, or substandard, is the lowest marketable quality. In the processed category of dried or dehydrated fruits, fruit and vegetable juices, canned and frozen, also preserves, jams, jellies, peanut butter, honey, ketchup, and tomato paste, we go on to the continuation. Grade A, very good flavor and color, few defects. Grade B, good flavor and color but not as uniform as A. Grade C, less flavor than B, color not as bright, and more defects. In the fresh category, the grade is more likely to be found without the shield. U.S. fancy, premium quality, only a few fruits and vegetables are packed in this grade, so they are rarely seen by most people. U.S. Fancy is the highest grade used in judging the quality of fresh vegetables, and it's based on appearance and uniform shape. U.S. number 1, this is the most common grade for fresh vegetables. It's given for those that appear fresh and tender, have good color, and are relatively free from bruises and decay. This is what we normally see in the grocery store. Then there's a U.S. number 2, which is an intermediate quality, and then number 3, the lowest marketable quality. Next time you're shopping for fruit or vegetables, see if you notice the grade, and that might help you remember. Selecting vegetables, it matters what season of the year is considered in season. Not all vegetables are in season at the same time. Figure 13-9 shows seasons for vegetables in terms of when they're in season, considered ripe. And I won't read this, but I think it's very interesting for you to have. Some of the vegetables are in season year-round. And this is important when you're planning menus so that you know if you can plan to have fresh vegetables and fruits in these categories. Of course, you can sometimes purchase frozen or canned, but in terms of fresh vegetables, these are the seasons. And this goes on for another couple figures. Okay, figure 13-9 continued. Here's some more. This would be endive through potatoes. Okay, and you notice there are some vegetables that are in season year-round. This is from R through Z. And notice spinach is a year-round vegetable, turnips, watercress, romaine, and then others. Notice some of the squash, the summer squash, you notice they're in season. The crookneck squash, which is the yellow squash, looks like July through October, whereas butternut squash is September through December. That's more of a winter squash. It's just a list of some common vegetables. And the reason they give you those is to contrast with some exotic vegetables that you may or may not have ever seen or tasted. These are some vegetables from around the world. We have Chinese long beans, Jerusalem artichoke, breadfruit, kohlrabi, himaka, Belgian endive, calabaza, chiote. Here's some more information about some of those exotic vegetables. Adzuki beans are native to the regions of East Asia and the Himalayas. They are commonly eaten in countries such as Korea, Japan, China, and other Asian nations. Chayote, or chayote, is a native Mexican plant, and it's also a member of the squash family. It's also referred to as a vegetable pear. In France, the chayote is called Christophine. The flesh is quite crisp, something like a water chestnut. The daikon, or daikon radish, is a white radish. This popular Asian vegetable bears little resemblance to small, round, red radishes found in tossed green salads. Jicama can be intimidating. If you haven't been formally introduced to the whole vegetable, you probably don't know what you are looking for. And once you know the tuberous form, they can be quite large with bark-like skin, perhaps even a little ominous. It's easy to forget how juicy, crunchy, and downright exciting they are. I hear it all the time when customers bite into jicama. That's a quote from thekitchen.com. Let's take a look at the artichoke. In figure 13-10, the major edible portion of an artichoke is the fleshy ends of the leaves attached to the plant. The heart is also edible and considered a delicacy. It is reached by lifting out the cone and cutting out the choke, or the core. You've probably heard of artichoke hearts. In figure 13-11, you see some images of preparing an artichoke. So you trim away both ends of the artichoke, and then you use scissors to cut away the barbs from the center of the artichoke. Figure 13-13 shows an array of leafy greens. Some of the major varieties of lettuce are iceberg, Boston or Bibb lettuce, endive, escarole, leaf lettuce, and romaine or Cost lettuce. The characteristics are listed here. This is table 13-3 in your textbook. Figure 13-14 shows a variety of cultivated mushrooms, from button mushrooms that are most common to portobello mushrooms and shiitake mushrooms, we see there is a variety with different flavors that we can use in our food preparation. Figure 13-15 shows some onion varieties. You may well know about these from your own cooking, but we have the white onion, the yellow all-purpose onion, the red onion, Vidalia onion, which has more of a sweet flavor, and pearl onions, which are used in soups and casseroles. These are regular onions whose growth has been stunted. Figure 13-16 shows chili peppers on the Scoville heat unit scale from bell peppers with a 0 rating all the way up to the Carolina Reaper. Figure 13-17 shows various types of potatoes, from red potatoes to russet Idaho potatoes to white potatoes, and then quite a few that you may not have seen before. Figure 13-18 shows some various types of squash, from spaghetti squash to acorn squash to zucchini squash to yellow crookneck squash. There are quite a few varieties of squash. And then figure 13-19 shows a selected variety of tomatoes, from cherry tomatoes to Roma tomatoes to grape tomatoes, and then your generic greenhouse tomato. These are some of the available tomatoes. Now let's talk about legumes. And here's a quote from Harvard from their public health page. I thought it was a good way to introduce legumes and also give you a definition. So let's just see what we have here. Although used interchangeably, the terms legumes, pulses, and beans have distinct meanings. A legume refers to any plant from the Fabaceae family that would include its leaves, stems, and pods. A pulse is the edible seed from the legume plant. Pulses include beans, lentils, and peas. For example, a pea pod is a legume, but the pea inside the pod is the pulse. The entire legume plant is often used in agricultural applications such as cover crops or livestock feed or fertilizers, while the seeds or pulses are what typically end up on our dinner plates. Beans in their various forms, kidney, black, pinto, navy, chickpeas, etc., are just one type of pulse. And you can go to this Nutrition Source Harvard webpage and learn a lot more about legumes and pulses. All legumes grow as seeds within a pod. Pulses include beans, peas, and lentils. They are excellent sources of fiber and other complex carbohydrates, protein, and iron. Soybeans are unique. They do have a relatively high protein and fat content. Here are some dried beans. You see black-eyed peas, navy beans, pinto beans, painted pony beans, lima beans. Then you have your fermented soybean foods. This would be your textured vegetable protein, your meat analogs, your tofu, and fermented soy foods. You see tofu used in vegetarian dishes to get the protein content up. Let's talk about cooking again. Why do we cook vegetables? We want to improve the palatability, improve and increase digestibility, improve utilization of protein from dried legumes, gelatinize starch, and destroy microorganisms. What happens during cooking can be changes to texture, flavor, odor, color, and nutrients. Factors that affect texture would be temperature. High temperature gelatinizes starch, decreases bulk by softening cellulose, and causes a reduction of turgor due to water loss. Acid or acidic foods, such as vinegar or tomatoes, should be added toward the end of the cooking time because they make vegetables more resistant to softening. Calcium salts are often added to pickles and canned vegetables to compensate for the turgor lost during processing. The salts combine with pectic substances, firming the food's texture. And adding alkaline ingredients such as baking soda causes hemicellulose to break down and produces a mushy texture. Soda has a destructive effect on thiamine. So you notice back in one of the previous slides, we talked about adding a bit of baking soda when cooking broccoli, for instance, but not too much because it can produce a mushy texture. Leaching is the greatest cause of nutrient loss, and we need to be careful how we prepare the vegetables so we can conserve the nutrients. So how do you do that? We've gone over this a little bit earlier, but let's review. Avoid immersing in water. Use as little cooking water as possible. Cook just to the point of doneness. Leave skins on vegetables, and cut vegetables in fewer pieces. And that way you minimize the surface area and minimize nutrient loss. Steaming takes a little longer than simmering, but it provides better retention of flavor, texture, and color. Microwaving is one of the best ways to retain a vegetable's texture, color, and nutrient content. And this requires very little water, and it's fast enough to minimize loss of quality. If you've noticed, in the frozen section, there are quite a few brands of vegetables that come in packages that are microwavable. You just put the whole bag in the microwave, and in 5 minutes you have vegetables ready to eat. You can simmer vegetables, but they should not be boiled, and they should be simmered in as little water as possible to avoid nutrient loss and adverse effects on color, flavor, and texture. And here you see the difference in boiling versus simmering. I thought you might find this interesting, degorging, especially if you like cucumbers and eggplant, but you want to eliminate the bitter flavor. Degorging is the process of drawing out a vegetable's moisture by sprinkling vegetables with salt before cooking. Also, degorge means to soak meat, poultry, or fish in cold water. This eliminates impurities such as blood and grit. It's most often done with freshwater fish to rid them of a muddy flavor. Table 13-4 shows the pigment color change in the presence of acid, alkali, heat, and metals. Why are we talking about metal? Well, that's because of the pans that we use to prepare the food. Dry heat preparation would be baking, roasting, and frying. And moist heat preparation would be simmering, steaming, braising, and microwaving. And notice we don't have boiling. Each of these terms is defined in a prior lecture. Talking about preparing legumes, there are several methods. The overnight soak method is where you soak the beans, the dry beans, for 8 to 12 hours. The short soak method is where you would briefly boil the legumes and then allow them to sit in the water for about an hour before cooking. The no-soak method involves pressure canning. We do know that legumes have some indigestible carbohydrates. You learn that in Chapter 3, Chemistry of Food Composition. And so you can take the enzyme that's found in the product called Beano, and that will provide the enzyme necessary to digest those carbohydrates. Table 13-5 shows the cooking time for beans after they have been soaked in the overnight soak method. Some people like to grow sprouts, and this is easily done with your legumes. Table 13-6 shows sprout preparation. So you have your legumes and vegetables listed here, the quantity, raw, the yield, how many rinses, how many days, and how high the sprouts grow in that amount of time. Storing vegetables is important. Some need to be refrigerated, and that has to do with the water content. Some vegetables are best stored at room temperature, for instance, potatoes. Some need to be stored in a crisper to maintain moisture. If you're going to freeze fresh vegetables, you want to blanch them first, and dry storage is appropriate for tomatoes, eggplant, winter squash, tubers, such as potatoes, dried legumes, and bulbs. We also have controlled atmosphere storage, and that is a type of packaging that limits the oxygen access to the vegetable. So in summary, we talked about drawing a plant diagram describing how vegetables are classified. We talked about a flow chart illustrating all the parts of the vegetable composition. We discussed factors influencing vegetable purchases. We defined legumes and their food products. We described ways to prepare vegetables using dry and moist heat. And we listed refrigeration, freezing, and dry methods of storing vegetables. This concludes the lesson on vegetables and legumes.